Kinetic energy versus potential energy. Understanding energy in motion and position. Kinetic energy and potential energy are fundamental concepts in physics that describe different forms of energy associated with the motion and position of objects. These concepts are essential for understanding the behavior of objects in various physical systems and their interactions with the environment. 1. Definition and characteristics. Kinetic energy is the energy an object possesses due to its motion. It depends on the mass of the object and its velocity, with faster-moving objects having higher kinetic energy. The formula for kinetic energy, K, is K equals 1/2 mv squared, where m is the mass of the object and v is its velocity. Kinetic energy is a scalar quantity measured in joules, J, and is transferred between objects during collisions or interactions. Potential energy, on the other hand, is the energy stored in an object due to its position relative to other objects or due to its configuration in a force field. Potential energy depends on factors such as the object's height, position in a gravitational or electric field, or its state within a chemical bond. Potential energy can be gravitational, Pe equals mgh, where h is height, elastic, Pe equals 1/2 kx squared, where k is the spring constant and x is displacement, or chemical, stored in chemical bonds. 2. Energy conversion. Kinetic energy can be converted into other forms of energy or transferred between objects during interactions. For example, when a moving object collides with another stationary object, its kinetic energy can cause deformation or motion in the second object, transferring some of its energy. Kinetic energy can also be converted into heat energy due to friction or air resistance, slowing down the object. Potential energy can be converted into kinetic energy as an object moves from a higher to a lower position in a gravitational field or as a spring compresses or extends. For example, a book held above the ground has gravitational potential energy that is converted into kinetic energy as it falls. Chemical potential energy stored in food is converted into kinetic energy in muscles during physical activity. 3. Nature of motion. Kinetic energy is associated with the actual motion of an object and is directly proportional to its mass and the square of its velocity. Objects in motion possess kinetic energy that depends on their speed and direction. Kinetic energy is a measure of the ability of an object to do work or cause a change in its environment due to its motion. Potential energy is related to the position or configuration of an object within a system. It is stored energy that can be released or converted into kinetic energy under the influence of forces such as gravity, elasticity, or chemical bonding. Potential energy is a measure of the work that can be done by an object or system due to its position or arrangement. 4. Examples and applications. Examples of kinetic energy include the motion of a moving car, a spinning turbine in a wind farm, a thrown baseball, or flowing water in a river. Kinetic energy is harnessed in various technologies such as kinetic energy recovery systems, (KERS), in vehicles and renewable energy sources like hydroelectric power. Examples of potential energy include a stretched rubber band, a pendulum at its highest point, water stored behind a dam, or a charged battery. Potential energy is crucial in gravitational potential energy systems, elastic potential energy devices like springs, and chemical potential energy in batteries and fuels used for energy storage. 5. Physics and dynamics. In physics, kinetic energy is associated with the motion and dynamics of objects in motion, governed by principles such as Newton's laws of motion and conservation of momentum. Kinetic energy influences the speed, acceleration, and collision behavior of objects, impacting their interactions and transformations in physical systems. Potential energy is integral to understanding the stability, equilibrium, and energy transformations in mechanical, gravitational, and electromagnetic systems. It influences the behavior of objects in fields such as engineering, astronomy, and chemistry, where energy stored in potential form determines system configurations and stability. Conclusion. Kinetic energy and potential energy are complementary concepts that describe different aspects of energy in physical systems. Kinetic energy pertains to the energy of motion, depending on an object's mass and velocity, while potential energy relates to the energy stored in position or configuration within a system. Understanding these forms of energy is essential for analyzing physical phenomena, designing technologies, and predicting interactions in natural and engineered systems, highlighting their fundamental roles in physics, engineering, and everyday life.